It's a Vermiponics presentation. Yeah. So vermiponics is at the junction of vermiculture and hydroponics. Vermiculture refers to raising worms for warm poop or beads. So warm poop is known in polite society as worm castings. And these are rich organic fertilizers from all types of plants. They are rich in nitrates, phosphates, potassium, and other helpful microbes and microbial life that helps to ensure that our plants grow nice and healthy. Hydroponics, on the other hand, is a method of growing plants in a water substrate often. So the water isn't just quite water by itself, it's a nutrient solution that usually has fertilizers in it so that plants can get that nitrates, phosphates, and potassium that they do need to grow and thrive as we would love them to. So on the trajectory of sustainability, vermiponics, I believe, is really on the cutting edge. And it also is the newest of all the ponics that I know of. So starting from, way back when, land farming is, it can be land and water intensive. It also has so many bad sides with, commercial agriculture. It's a commercial agriculture is a whole other can of worms. But one of the issues do include deforestation. Hey, baby. Deforestation brings us closer in contact with wild animals, not to talk of destroying their habitats. And it can spread diseases and so many other bad things. Hydroponics is a step up. It uses so much less land, uses a lot less water, but it also uses artificial fertilizers because plants need to get their nutrients, their food some way or another. And the system can be frail and is vulnerable to waterborne diseases. So just a little downside there. Aquaponics is another step up because you're using fish poop and fish pee as your fertilizer of choice. But your fish have to be kept alive, and fish food is often made with conventional agriculture with sea caught fish. Which increases the footprint that that fish food actually has, and aquaponics as a result has, which is negative. The fish have to be kept alive, which is not a particularly easy task. A lot of the time, fish can be extremely frail. And because fish are frail, the system as a whole is frail because you have to balance a lot of different things, like the ammonia from fish poop and pee has to be, filtered and sorted, all that stuff. And we also have low microbial diversity within the aquaponic system, and it can be expensive to set up because, depending on the type of fish, you have to depending on the type of fish, you have to sorry, the word's not coming to me right now. Yeah, but depending on the type of fish, you have to give it like a different sort of heating or temperature control because fish like tilapia, for example, usually would prefer a little warmer conditions. But in vermiponics, we have no such calms. We've got worms. Worms are extremely they're extremely durable. They can survive a whole host of situations. a range of temperatures, but at the same time, like, there's limits to it. We're not trying to, torture worms, see how far we can push them. But yeah, worms are a bit more durable, they're a little stronger. They also do help to decompose waste from the kitchen, which is a big bonus because that's less waste going to landfills, and we also have a more circular system, and it produces healthier fertilizers. So here we have a little head-to-head, tete-a-tete between worm castings and commercial fertilizers. So first we have to describe what NPKs are. So NPK is a ratio of nitrates, phosphates, and potassium in a given fertilizer, and it's a percentage of the total fertilizer, content. So for flowering plants like tomatoes, eggplants, beans, melons, what kind of flowers are there? Roses, violets, lilies, I guess, flowers in general. The optimal NPK ratio is 3:1:2. So that's of the entire makeup, 30% is nitrates, 10% is potassium, is phosphate, sorry, and 2% is potassium. Some people call it potash. I don't think they're cool at all. I think potassium is a better name for the chemical, for the element, sorry. So worm castings, they have an NPK ratio of 5:3, so that's they generally have an NPK ratio of 5:3, and they have rich microbial life because there is a lot of microbes and fungi and all those sort of things in worms' guts and around them when food is being decomposed. And these microbes are good microbes, and that help to protect plants from pests and diseases like wilt disease, top crown and root rot as well, and pests like mites find it's especially hard to mess with your plants when you've got worm castings present. Sorry, my cat is being very needy for attention. I need to play with her soon, or she'll start biting everything. Yeah, humuses. There's a lot of humus in worm castings, which help to improve the water retention of the soil, and organic matter as well helps to improve that soil composition. In commercial fertilizers, on the other hand, boo, yeah, we have varied NPK ratings for different situations and different desired outcomes. So a common ratio is 10-10-10 or 20-20-20. They tout themselves as balanced. They promote super fast growth that makes them easy prey for pest and disease, because pets are like pest and disease are like, oh wow, look at this distinguished gentleman. Look at this nice little plant growing big and strong. Well, big, not so strong, but you're growing pretty fast. And then the pest and prey are like, well, the pest and disease are like, well, okay, what if we just come infect/nibble on this little beauty here who doesn't have the necessary protections, and because they've just grown so quickly without developing themselves, they just become much easier prey. And commercial fertilizers are also rich in concentrated chemical salts, some of which were initially intended for use in explosives. There's some things that you could do with ammonium nitrate that makes things go boom boom. But I did not tell that to you. You did not hear it from me. I did not disclose that sort of information. I don't go that way, answering that way. Yeah, but there's just some bad parts of chemical fertilizers. So like we said earlier, vermiponics is, just the marriage of vermiculture over here in the warm bin, and hydroponics over here in the little hydroponics thing. And this is a oversimplified system diagram of it. So we get water from a water source. We like to be sustainable and save rainwater. So we get that rainwater, and that rainwater goes into the warm bins, and that water is circulated a few times so that it gets really rich with the warm poop and all the microbes and micronutrients in that area where the worms are doing their business. Eventually that water is, pumped out and, filtered of bigger particles and pumped out to a reservoir. In this reservoir, we would usually aerate this warm tea so that nitrification can happen. Nitrification is the process by which ammonia oxidizes into nitrites, which is, how plants can take it up. So that's an essential little activity there that happens in the reservoir. From the reservoir, it's pumped into your hydroponic structure, so it gets into the roots of your plants. And excess water is, taken over into the warm bin. So we could go again. We could also do this with an irrigation system, as long as we're able to collect all that wastewater. I know a lot of it will get trapped in the soil, which is not a bad thing at all, because, the soil also gets a lot of that richness that the warm tea brings. But yeah, we just get a little bit less water, probably a lot less water when we use it in irrigation system. So we need more rainwater, or maybe like more water from your house, from your pumps, from your outside pumps, really. So these are some people that have done pretty well in the vermiponics fair. On the top right, we have a farmer from Australia who's actually a flower farmer primarily. And all these plants here, all these cute little budding flowers are, they're given the warm tea through irrigation. So the sprinklers go off and, just drench their leaves in the rich goodness of warm tea. Yeah. So his reporter just like having to cut down a lot on his chemical on the money he spends on, just chemicals and chemical fertilizers, because of how well the warm tea works. Down here in the bottom right corner, we have someone that uses a system much more similar to ours, because they use a vermiponics setup actually. So on the left here is no small feat of engineering, really a marvel in its own right. It is the warm, I keep forgetting what this is called. What's it called again? The warm tea? Warm tap. The warm tap, that's what it is. So we've got worms in 1, 2, 3, 4, 5. We've got worms in these top 5 drawers in here, and I really like the drawer system because it just makes it so much easier for accessibility, which is what we love to see. This is what we enjoy seeing. This is why we're here. This is the reason for the season. So sorry, I got a bit carried away there. So water gets in from the back, it's pumped up to the top, and it just drenches down slowly. This goes on about twice a day, and then in the bottom here is a steel tank with where the reservoir is, and in that reservoir the water is you know aerated, and which helps all the nitrification, which is essential for the plant to happen. That's where all the good things. That's where all the good things happen. And then you open your tap and you get liquid gold. Yeah, which is really fantastic. And I think this design is really phenomenal because it just brings together both the warm bin and the it marries the warm bin with the reservoir system, which just streamlines the whole process. The only downside, of course, is that we have very small capacity in this reservoir actually, but there is a high output. I think north of 1.5 gallons a day is what they reported. So it's a really nice design, really nice system. You could get it for the low price of about north of $700. So it's a pretty penny. Might be worth it if you've got a hydroponic system, but I'm sure there's a cheaper way to do it, which is what we will be figuring out. Well, thank you guys for coming to my TED Talk. Do you have questions, suggestions, anything, thoughts on how we can actualize it if you've seen the garden? If you have not seen the garden, it is on 34th and Spring Garden. It's a big garden, you can't miss it. Yeah, we would love to have you come around sometime as well. So yeah, I'll just open the floor up to any questions, any suggestions, concerns, anything.
Yeah, quick question. So, or two questions. First, the worms, right? They're living a life in the soil. It's great. But what happens when they die? Are they just going to be absorbed into the soil, or are you going to go out of your way to keep track of that?
Oh no, darling, it's over here. It's from Earth to Earth, baby. They die and then their friends decompose them.
Yeah, like that's cycle life. That's it.
It's cycle of life, we have to keep it circular. That's the whole idea here.
Cool, cool. And then if this is a great idea because yeah, both systems kind of feed each other and they can work off each other and it's efficient. Um, but if you do this like on a large scale, like if a country wanted to grow like a national grain, whatever they export the most, that would probably require a lot of water. Where are you bringing that water in? How often is like the water being like, are you changing it out to keep it clean, blah, blah, blah. Could it be done on like a mass scale like that?
Yeah, so you might have some issues with scaling it up. This guy, our little flower farm actually has it on a pretty big scale.
Mhm.
Yeah, so what he does is he does have like multiple warm beds, and he has like several tanks, and I imagine that he's got one tank that gets like all the excess water back from the system and filters it out a little bit more completely.
Cool.
So yeah, so it's a bit more circular in that extent, but you would still need, a root source of water. So for the warm tap, what some people do is that they just plug it into like, the water that they would have used to spray their crops or whatever.
Mhm.
Yeah. You also will have some issues with the buildup of nutrients as time goes on.
Mhm.
So we have to be mindful of that and watch out for that because when especially because the water is recycled into the worm bin, right? So it too much nutrients, if it's too rich, it can actually kill our worms. So that is something that we have to actively look out for. Maybe have like maybe measure it, then decide, okay, is it good time to rinse through the system or not? That sort of thing.
Yeah, there's just like a lot of things it seems to keep track of. And when you keep track of it all and it's kept up, it works really well.
Oh
But
yeah.
anything starts to like be forgotten or just starts to go awry, that kind of seems, because the system is driven, everything goes awry. So it's a different type of agriculture. Very cool stuff though. Go worms.
Yeah, go worms. We're actually getting that printed very soon on all our shirts, and we are going to have a massive propaganda campaign on campus. Go worms.
Absolutely, absolutely. Well, I'll definitely spread the word. Go worms. Thank you.
Right, no problem, Harley. Yeah, so the floor is open, stack is open, as my commie friends will say. If you have questions, suggestions, ideas, I would love to, talk more with you guys. Before I have to go back and re-record this whole thing.
First of all, I'm so sorry you have to go back and re-record the whole thing because that's awful. I know you have a vermiculture system set up at the Lindy Center. Are you going to try to do like a vermiponics or what are you going to be using that for?
So right now our focus for that system was just to supply worm castings as a source of fertilizer for our beds. So in the future we might do it because it is a little capital intensive. So we do need like a little bit of brainstorming and having all our good engineer people on the task. But we've actually recently we got about a little more than 10 grams. I want to say between 10 and 20 grams of worm castings from our worm bin. So we've already had a little harvest. And with that, we could do one of two things. We could either just, throw them in the soil when we're back to planting, or we could make tea with it. We could make some of the worm tea and maybe compare and contrast which works better with two different beds. It's like, oh, okay, is it better to have the warm castings or the warm tea, or do both help more than just one or the other? So yeah, we definitely have we definitely will have something like this in the future. We just need to, flesh it out and think it out and see more specifically what other people have done. Yeah, I think there's also a university in Michigan that actually has a little vermiponics setup. But they did this like a while back in like 2008. But I think the most recent update was like 2019, and the little vermiponics setup helped them to get their greenhouse certified. It's like yeah.
That's real cool.
Yeah, it's really exciting stuff. Yeah. All right. So barring any more questions, thank you guys so much for being here, sharing this time of warm discovery and warm learning